So, if I ask you for instantaneous rate of change at a particular value of x, I want the slope of the tangent at that particular point. Okay, but in grade 9, to find slope, how many points did you need? 2 points are needed. But I'm asking you to find the slope after giving you just 1 point. So this is something new, right? How can you do that? So we can't actually, not without this concept called limits. The best we can do is approximate. So this is what we do instead. We pick another point, and we pick just a little bit away from x. So let's call that little distance h. This becomes x plus h. Okay, and then this y value here becomes what? F at x plus h. Okay, and then we find the slope between those two, that's secant. Like that. So let's write the slope of the secant. Okay, let's find delta y over delta x. So, see this distance right here? That's f at x plus h minus f at x, according to the diagram that I have. And see this distance right here? That's just h. Okay, this is called differential quotient.
Is that the formula for using limit?
Differential quotient. So this is what we do. Here's a nice formula we have, okay? For 2 points, provided that h is not 0. But as we shrink h, what happens to the slope? What happens to this? The delta y over delta x?
It's smaller.
It gets, see this tilt? This tilt will get closer to the tangent. I don't have an animation here, but do you see that as this gets closer, right? This h shrinks, this will go up towards the tangent, right? In other words, see this point? As it gets closer to where the point is on the x, right beside it, then the actual secant will get closer to the actual tangent, right? So typically in advanced functions, what we do is we pick 2 points that are really, really close to each other and plug into this formula, and that's your estimation of the instantaneous rate of change. The smaller you pick h, the better it is. So let's do an example.